Hello everyone, I just wanted to provide kind of a quick video of the process of factoring a quadratic equation using the slide and divide method whenever you have a coefficient on x squared that's bigger than 1. So if you're given an equation like this, the first thing that we would want to do is we would want to get everything to one side of the equation and have it set equal to 0 so that way we can factor it. In this case, I would just push everything from one side over here to the side where x squared is. I'd like to keep that coefficient on x squared positive. And so I would do that by subtracting 3x and subtracting 7 from both sides of the equation. And that's going to leave me with 0 over here, and then the expression on the other side is 15x squared, negative 8x, and negative 3x is negative 11x. Negative 7 and negative 7 is minus 14. Okay, now that I've got my quadratic equation set equal to 0, this is where we come in with the slide part in slide and divide. So the idea is that I'm going to change this equation so that way it looks like 1 where a is equal to 1 to make it easier for me to factor. And so what we do is we take that coefficient on x squared and we slide it in to the constant over here, right? So we're just going to multiply them together. That will give me an equation where my a is 1, right? It's just going to change it a little bit. X squared, the minus 11x doesn't change, but we've multiplied 15 times negative 14 to give us negative 210, still equal to 0. Now, I want to factor this just like we would any other quadratic equation where a is equal to 1, right? So I should have x plus or minus a number times x plus or minus another number. We just have to kind of do a little bit of work to figure out what those numbers are going to be. So I'm looking for factors of, normally looking for factors of a times c, right? But in this case, right, where a is 1, I'm just looking for factors of c. So I'm looking for factors of negative 210. I want these factors to multiply together to give me negative 210, but to add together to give me that negative 11, the coefficient on x. So I always start by using 1 and the number, and then I kind of work my way up from 1. So I start thinking, is 2 a factor? Yes, it is. That's 2 times negative 105. Is 3 a factor? Yes, it is. 3 and negative 70 will get me there. What about 4? No, 4 doesn't work. 5 is a factor. 5 times negative 42 would be negative 210. There's a lot of factors here. But again, I'm just looking for the pair that adds up to negative 11. What about 6? Yep, 2 and 3 are both factors, so that means 6 it would be 6 times negative 35. 7 is also a factor, 7 times negative 30. What about 8? No, 8 doesn't work. 9? No. What about 10? 10 is a factor, 10 and negative 21, right? And we could keep going and start listing factors, right? We know that 15 and negative 14 are also ones, but we don't need to because we've already run across the pair of factors that I need. 10 and negative 21 are the two factors that multiply together to give me negative 210 and add together to give me negative 11. So those are the factors that I need in here. So those are going to come into my parentheses here. I've got x and a positive 10 and x minus 21. Okay. Now here is where the divide part comes out, right? We have to keep into account that we slid this 15 into that number that we factored. So we have to go back into these numbers and we have to find that 15 and divide it back out. Well, neither of these numbers can be divided by 15 evenly. So it's possible that your coefficient on a could be hiding in one of these numbers, right? Or it could exist in both of them, right? And so that's what we kind of have to do here. We have to do a little trick and think, well, 15 can be thought of as 5 times 3. Right? So if I look for the factors of 15 instead of 15 itself, then I can find them inside of those numbers. I can see that 10 is 5 times 2, and 21 is 7 times 3. Right? So I can find my factors in here. Right? I was looking for that 5 and that 3. So what's going to happen is we have to divide them out. So when we divide out the 3, we're going to put it in front of the x in the opposite factor. Same thing with the 5 over here. When we divide out this 5, we're going to put it in front of the x in the opposite factor. All right, so the factors that we're going to end up with are going to be 3 is going to be in front here, 3x, plus what's left when we divide out the 5 is just that 2. We get 3x plus 2. And then this factor is going to be, we divided the 5 and put it in front of this one, so it's 5x minus whatever we have left here. So it's going to be 5x minus 7. All right, these are our two factors here, still equal to 0. So all we have to do now is go through and set each one of these factors equal to 0 to come up with our solutions. Take 3x plus 2, set that equal to 0. Take 5x minus 7 and set that equal to 0. Then going through and solving, I'm going to subtract 2 from both sides here to get that 3x is equal to negative 2. And then dividing away the coefficient tells me that x is equal to negative 2/3. And then to solve this equation, I'm going to add 7 to both sides, giving me 5x is equal to 7. And then I'm going to divide away my coefficient here to find out that x is equal to 7/5. All right, so there's my two solutions to this quadratic equation. Came from this process of slide and divide, where we take the coefficient and slide it into the constant over here to make it a little bit easier to factor. We just have to keep track of what we did and then go in and find it once we get it factored and pull those back out. Right? So sometimes it works out nicely where it just moves from one number into the other factor. Sometimes we have to split it up into a product and pull it out piece by piece. So I hope this process helps you out. This video is useful for you. I'm also going to show you a few practice problems that you can use in order to try this method out. Here's a couple of problems that you can go and practice yourself using this method, or you can check the other video that I have for the box method as well.